This is sample problem 15.7. At 375 degrees Celsius, the equilibrium constant for the reaction N2 gas plus 3H2 gas becomes 2NH3 gas is 1.2. At the start of the reaction, the concentrations of nitrogen, hydrogen, and ammonia are 0.071 molar, 9.2 times 10 to the negative 3 molar, and 1.83 times 10 to the negative 4 molar, respectively. Determine whether this system is at equilibrium, and if not, determine which direction it must proceed to establish equilibrium. So what I'm going to do is I'm going to write this equation here a little bit bigger. So nitrogen plus 3 hydrogens forms 2 ammonias, all of them gas phase. We are told that Kc is equal to 1.2, right? Let's see where it says that. The way they often word these problems, or the way they type them in the textbook, I notice, is that the number that you need in one of the steps is usually like right after the equation. They didn't just put Kc equals 1.2 to the right of the equation. It would have been nice if they did that. But it does say in there that Kc is equal to 1.2. And what is Kc? Kc is the concentrations of the products. So ammonia is the product at equilibrium squared, divided by the concentration of nitrogen at equilibrium times the concentration of hydrogen at equilibrium to the third power, right? Remember, those coefficients become the exponents in that expression. But we also have the reaction quotient, Qc. And Qc is, again, it's the concentration of ammonia squared divided by the concentration of nitrogen divided by the concentration of hydrogen cubed, but using the values that are given, because we don't know for an equilibrium yet. So let's figure out, it looks like the ammonia is 1.83 times 10 to the minus 4. But we square that. And then we divide that by the nitrogen, which is 0.071. And then the hydrogen is 9.2 times 10 to the minus 3. And then we're going to cube that. Okay, so now we got to go through that calculation. So we'll pull out our calculator. And it's 1.83 times 10 to the minus 4. And then we got to square it. Okay, so that is 3.35. Actually, let me go ahead and write it down. 3.349 times 10 to the minus 8, right? And then we're going to do the denominator. So it's 0.071 times 9.2 times 10 to the minus 3. And then we got to raise that to the third power. So your calculator should have a third power. And it looks to me as though I've got 1.815 times 10 to the minus 15. I'm going to check that. So I'm going to check it by taking 9.2 times 10 to the minus 3 times 9.2 times 10 to the minus 3 times 9.2 times 10 to the minus 3, and then times 0.071. And yes, that is right. So it's 5.53 times 10 to the minus 8. Okay, so actually that number there Looks like it's going to be the 10 to the minus 8 cancel. That's kind of sweet. So now you just have 3.349 divided by 5.53, which is 0.606. Okay, so that, to be honest with you, it's not that far off. It's pretty close, but it is a little smaller than 1.2. So here, if we recall back in sample problem 15.6, the idea is that if Q is less than K, then the reaction goes to the right. And if Q is greater than K, then the reaction goes to the left. Okay? So 6.606 is less than 1.2, right? So Q is less than K. So that's this case right here, which means it's going to go that way. Okay, so this doesn't ask you to do any calculations based on that, just to predict which direction it's going to go. We could answer by just saying it's going to go to the right. But we could also say, look, this is going to go up by 2x because of that 2 there. And then this is going to go down by 3x. And then this is going to go down by x. 1x, really. Okay? So there you go. Sample problem 15.7.